Okay, this is practice exam number 1 for the Chapter 7 test. And in this very first problem, you are given a quotient made out of trig functions. And the directions for this problem is to write this expression as either a constant, if that's what the answer comes out to be, or a single trig function, it may turn out that way, or a power of a trig function. There's only one correct answer if you simplify it completely, which of course you're expected to do. So what you're doing with these, when you're doing something like this, one of the most suggested ways of doing this is to take everything and re-express it, anything that can be re-expressed, in its sine cosine form. You can't re-express the word sine or cosine because those are the basic building blocks of everything else. But anything more elevated than sine or cosine, you can re-express it using its definition, or what we call its identity. So here we go. I'm going to leave cosine the way it is. And by the way, when you're going to work the problem going sideways, you might want to label your steps. This is step 1 for me, where I'm rewriting this quotient. Cosecant, there is another way of expressing cosecant, which is called, you could either call it the formula for cosecant, the definition, you could call it the identity for cosecant. It is equal to 1 over sine, the reciprocal of sine. That's cosecant. So in place of that, I put sine. Because when you rewrite things in terms of their sine, cosine definitions, that's what allows you to see very easily what cancels out. Down on the bottom, there's a definition for tan. That is defined as sine over cosine. So you need to know these quotient identities very well. Okay, then on the top, let's bring this all together as one term. Cosine is the same thing as cosine over 1. So cosine's in the numerator, multiply it by the other numerator. So numerator times numerator, and then 1 times sine for the product of the denominators. Okay, that's the top of this big complex fraction. Okay, then on the bottom, of course, all you have is sine over cosine. Being that you have a complex fraction, you're going to simplify it as we have simplified complex fractions in all chapters. You take the denominator, which is this quotient down here, float it to the top, and flip it over. In other words, you are going to be, instead of dividing, you're going to be multiplying by the reciprocal of the denominator, which is actually the definition of division, multiplying by the reciprocal. So flipping this over, we get cosine over sine. Don't look at this anymore because you've already used it. It's up at the top. Now multiply again. When you're multiplying fractions, numerator times numerator, denominator times denominator. So this was my second step. When you label these steps, step 1, step 2, you don't need to write the word step, then I can follow your chain of thought. Okay, so please label as you go along. This will be step 3 for me. Now I'm going to go top times top, giving me cosine squared. The square goes on the trig word, not the theta. And then bottom times bottom. So that's sine squared. Sine times sine is sine squared. Square goes on the trig word. And then finally, rename this as a single trig function, just like the directions said, that you could either give your answer as a constant, which this did not come out to be a constant. A constant's a number. Or a single trig function with only one trig word in it. That's what single means. Or it could be a trig function with a power, which it's going to be a single trig function, but it's also going to have a power in it. So this is going to be the one trig word. I forgot the co. One trig word that this is equal to. Cosine over sine is cotangent. But since both of these are in this squared form, it's cotangent squared. So you have a single trig word, but with a power. And that's because these were both raised to a power of 2. That's your final answer. Okay, problem number 2. Now this would be considered level 1 because you're not really doing much algebra there. All you're doing is simplifying a complex fraction. The ones that are heavier in the algebra, like for instance, you have to either FOIL or factor, and those are skills that are considered much harder than simplifying a complex fraction. Well, a little harder than simplifying a complex fraction. So this would be more like level 2. Recognize when you're being, like for instance, some students don't understand that if they're given, even though they've come through many algebra classes, they don't understand that if they see something like this, foiling. Because the minute you see a square on something, that does not mean, although many students get it wrong for this reason, they think that means square this, square that. It most definitely does not mean that. When you square something, it means take the entire expression and multiply it by itself. And you're expected to recognize that at this point, like I said, after coming through several algebra classes. And that's foiling, which means you get 4 different products. You don't just get this and this. There are 2 other terms. So that is what you're seeing in this problem. You're not seeing a square, excuse me, but it is foiling. You have a binomial, 2 terms, that's a binomial, times 2 other terms, and that is foiling. So for foiling, it's that F stands for first times first. The O in FOIL stands for outer times outer. The I in FOIL stands for inner times inner. And the L in FOIL stands for last times last. So out of this first term, you're going to draw an arrow to each of the terms in the other parenthesis. From this second term, you will also draw an arrow to each of the terms in the other parenthesis and follow them to get the 4 terms in your answer, or the 4 terms in the foiling part of this problem. It's not the final answer yet. So follow the short one right here, and it'd be 1 times 1 is 1. Following this long arrow up top, that would be 1 times positive cosecant. And be very clear that you're keeping everything on the right side. Don't start, going back and forth so I can follow what you're doing. When you have a left and a right side, if you are working on the right side, do not pass over this equal sign. Keep all the work associated with the right side actually on the right side. Okay, continuing the foiling, I now have to do, so it's negative cosecant times 1, negative cosecant. Negative cosecant times positive cosecant would be negative cosecant squared. Cosecant times cosecant, cosecant squared. With the x there, the square goes on the trig word, not the angle. They happen to be using x for the angle here. Combine like terms. Like terms would be this and this. One's a positive, one's a negative. Therefore, they cancel. And you are left just with the 1 minus cosecant squared. Now, you have not completed this identity until you get both sides to match. They don't match yet. So you need to come off to the side and show me why you are about, how and why has led you into the next step that you have to do, the final step. Okay, this has to do with Pythagorean identities. The Pythagorean identities, there are 3 of them, and they all have squares on them. Those are the 3 identities. One of them is cosine squared plus sine squared is equal to 1. There's another one that goes 1 plus tan squared is equal to secant squared. And the one we want has these 2 words in it. That's why you have to practice these practice exams so many times so that you know those formulas down cold. There are 3 Pythagorean identities. This is one of them. 1 plus, and you can just come off to the side and state this to yourself because sometimes you get to use them in their original forms and sometimes they have to be manipulated. But anyway, it goes like this. 1 plus cotan squared is equal to cosecant squared. That's the Pythagorean identity that incorporates those 2 words. If you manipulate it, you'll be able to make this Pythagorean identity look just like what you have right here. All you have to do is move things around a little bit. Now you want it to look like this. You want one of these sides to look just like this. So 1 minus cosecant squared, you'd have to bring this over here where the 1 is, and then it would say 1 minus cosecant squared, because as we, what this arrow means is that I'm subtracting cosecant squared here, subtracting cosecant squared here, which is its sign. So it was positive over here, it's negative over here. You'd also have to move this cotan squared to the opposite side, which would also change its sign. Okay, so as soon as you get here, you can come right here and you can put negative cotan squared. Now look at what you have here. Have you been able to prove that these are identical? Have you been able to prove that this is an identity? Look at what these instructions say, because sometimes you're going to be given something that is not possible to prove. It's not possible to prove that they're identical because they're not identical. And the directions will somewhat give you a hint. See how it says determine whether the equation is an identity? We have tried to do that. We've done everything in our power in order to do the substitutions and the algebraic manipulations. And when all was said and done, even though this was written properly, and we moved the cotan over here, it became negative. And the cosecant, when it came over here, became negative. So it looked exactly like this. And we were able to plug in negative cotan squared for what it's equal to. But in the end game, they are different by way of this negative that's out front. So are these two sides identical? This is not an identity. That's your determination. But you still have to go at it as though you were trying to prove that it's an identity, and you will discover at the end whether it is or not. Okay, next one for number 3. Problem number 3 just says simplify the expression. So again, one of the best ways to do that is to try and there are more than one way to do these problems, but typically that's probably one of the first things I always try. And if I see that it's not working, I just scrap that effort and try it a different way. But you have to be clued into the fact that in many of these problems, you are being prompted to start the problem with algebra rather than substituting in words. Like for instance, I would not start plugging in the sine cosine definitions yet. I would respond to, what does this mean to have a multiplier in front of the parentheses? It means that you're distributing. So you're going to be distributing tan of x to cosecant and tan of x to cotan of x. Just like when you were in this problem, what were you being prompted to do first? To FOIL. Always when you see 2 terms times 2 terms, binomial times binomial, you're FOILing. And then because everything was coming out squared, I went with the Pythagorean identity as my way to substitute rather than going sine cosine. You don't always replace things with their sine cosine definitions. Here, that was suggested because everything was first degree as I went through the problem. Not until I got to the end, by way of the substitutions that I did those second degrees come about. But when things are first degree, very good idea to try the sine cosine definitions. When you see that the problem involves a lot of squares, is because they're trying to get you to use the Pythagorean identities as a way to substitute one thing for another. Okay, but here, I'm going to respond to the algebra that I'm being prompted into doing right now. I'm going to distribute tan to cosecant, and you know that tan, when you distribute, you're just multiplying. So we're going to make a product, tan times cosecant. Then the next product will be tan times cotan. But this is positive times negative, so it's going to be negative tan times cotan. And then drop that secant into the scenario. Okay, so then let's see. What do we have here? Let's see. I think what I'm going to do is start going sine, cosine definitions. That's because everything's first degree, so I'm going to try it. I'm going to call tan by its definition, which is sine over cosine. Times cosecant, which is 1 over sine. And I think I'm going to keep going with this. I mean, I'm already noticing, just because I'm thinking ahead, that this is equal to this back term. I'll go and rename this in a second, but look real quick that the signs cancel, right? So then you'd be left with just 1 over cosine for this very first term. And the other name for 1 over cosine is secant. So I already know that I have a secant in the front and a negative secant in the back. So I'm not going to bother renaming this 1 over cosine because these two are already going to take each other out. The only thing that I have left in this game is this negative tan times cotan. Let's see what that turns out to be. This one would be sine over cosine, while this one, you might already be thinking ahead, would be cosine over sine. So do you see that this cancels with this and this numerator cancels with that? So what you have as this middle term is negative 1. You have everything cancels. That means that it simplifies to 1. So that middle term was 1. So in the end of this problem, secant in the front canceled with the secant in the back, and your final answer is just negative 1. Okay, problem number 4. Problem number 4 asks you to find the sine of 11 pi over 12. And the directions just say use an appropriate identity, which means that you can do it more than one way. But what I like to do, and the first thing you might want to do is, I think that you're probably more successful when you are doing these problems in degrees. So you might want to change this into degrees. So in your calculator, you can just put in 11 times 180, that's what pi is, 11 times 180 divided by 12. Go ahead and do that. Let me grab my calculator. Whoops. Okay, so 11 times 180 divided by 12, that would be 160. I think you should start by doing that. You're welcome to leave it in radian form, but it'll probably just be harder for you. Now these weird angles like this that we did not study in chapter 6, we only studied how to get exact values for things that have to do with special right triangles, either a 30, a 60, or a 45. So what you want to do is split up this 165 into numbers that are related to those angles, that either are those angles or are related to those angles by way of a reference angle. So I know that the special right triangles that I learned and that you learned, that I taught you, has to do with 30, 60, and 45. Now you see that this is the only one that ends in 5, and this number ends in 5. So one of the numbers that you're going to split this up into is going to be the 45, and you can either do the other one in your head or subtract. Okay, 45 plus what gives you 165? That would be 120. Okay, since I have added 2 angles in order to create this 165, I am going to be using the sum formulas for sine. And that goes like that. Again, you need to be able to pull this formula out of your head in the middle of what you're doing. So you have to spend a lot of time practicing to help you memorize the formulas. And I would even go further and make some formula cards for the things that were taught in this section. You're going to be using the quotient identities a lot when you do the verification and simplifying problems like I did in 1, 2, and 3, and the Pythagorean identities. Those are the ones you're going to be using the most. Pythagorean identities and the quotient formulas. Quotient formulas being like tan is equal to sine over cosine. cosecant is equal to 1 over sine. You know, when you're expressing the trig word as a fraction, which you can only do for tan, cotan, secant, and cosecant, not for the basic building blocks of sine and cosine. So you also need to know these formulas. When you're doing a sum, that formula having to do with sine goes like this. It's a hybrid type of formula. In other words, for these sine and cosine sum form, whether they're sum or difference formulas, they have a product in the front and a product in the back. And when I say that it is a hybrid product, that means it's a mixture of both sine and cosine in both the front and back products. And that's how all the sine formulas are when you're doing a sum. Okay, it goes like this. A little bit of sine, a little bit of cosine. It's a mixture. The angles go right here. Okay, you have to have memorized what is the relationship between what you see here and what you put in the expansion. For the sine formulas, the signs are the same. Whether it's in its condensed form or whether it's in this long expanded form, they're the same. So plus sign here as well. And then another hybrid mixture. A little bit of sine, a little bit of cosine. Only what happens in this back product is that these two angles switch. The 45 will now be with the cosine, and the 120 will be with the sine. All right, now you have to know the values that represent the sine at 45. You may have that memorized already. A lot of students have it memorized at this point, and that's just because it's easy to remember. Both legs are equal. They are both square root of 2 over 2, all these special right triangles being having a radius of 1. So this is what happens when you have a 45-degree triangle. So the sine is always the vertical leg, the leg that runs up and down. Cosine is always the horizontal leg, the leg that runs horizontally across. Okay, so we're going to do a product here. That's what sine times cosine means. We're going to do a product here. We need not only a 45-degree special right triangle, but we need to know what is associated with a spin of 120. So when we spin to 120, we're in quadrant 2. The way to 120, that means we are 60 degrees away from the 180 mark. This would be 60 degrees. This would be 120 where this hypotenuse is, with 60 degrees short of making the 180 mark, which is the pi location. Come down. Triangle, you need to attach values to the legs, the vertical leg as well as the horizontal leg. Always across from the 60-degree angle will be what we call the long leg. Remember, the vertical leg represents the sine. And then if this is 60, this would be 30 up here. Always across from the 30 is the short leg. And the short leg happens to be negative in this case. Remember, the horizontal leg represents the cosine. Also remember, just so you'll understand why things are positive and negative, cosine is the same thing as x. And the sine is the same thing as y. Well, when you're in quadrant 2, y values are positive, and that's why that's positive. That's square root of 3 over 2. And the cosine, which is like the x value, x's are negative over here. That's why there's a negative there. So that goes on throughout the entire book, every chapter that you go into. Now you have everything you need. There are no decimals on this test. You will be showing that you know how to draw and get the answers from the picture. If you want to leave something out like that because you already have them memorized, do that, but at least give me one picture and show me how you develop the answers that you are popping into your answer right here. Because if you have multiple choice, it's only going to be a couple of problems. You need to know how to write the solution, how to develop and show me every step. Okay, here we go. Sine, you're at the 45, the sine of the 45, that leg right there. But the cosine is also square root of 2 over 2. So I'll go ahead and put that in. That goes right in here. Cosine of 45. So square root of 2 over 2. So I knocked both of those two out. Cosine at 120. Well, here's my picture I developed when I rotated to 120. It ended up being a 30, 60, 90. With the sine value being square root of 3 over 2. That goes here for sine. And the cosine ended up being negative 1/2. Okay, now multiply, as you always multiply fractions. Top times top, numerator times numerator, denominator times denominator. Here, top times top, square root of 6. When you're multiplying two radicals that are the same type of radical, square roots, you just multiply the radicals. That's the 3 and the 2. Denominator is 4, and you can give me the answer like that, or you can bring it into a single fraction if you'd like. You know, when the denominators are the same, that's really easy to do. Either way is acceptable. Okay, so you can give me this or that, either one. We'll get you full credit. Okay, in the next videos that you're going to see, we will, tackle 4 or 5 problems at a time.